everyone, welcome to channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your chemistry class, and that is your 18th class. We had done your 17th class of the session in the last classes, and where we had completed your part 1 with till unit 7, and unit 8 which we had started with is your unit 8 is your redox reaction. Unit 9 is your the hydrogen, and the unit 10 which we had started with and will be surely continuing in this class, and that is your unit 10 is your the is block element. Okay, so the S block elements that we discussed here. In the same way, where we had completed about the reactivity towards the water, reactivity towards dihydrogen, reactivity towards halogens, reactivity in reducing nature, uses, solutions in the liquid, ammonia, general characteristics of the compound of the alkali metal, oxides and hydroxides, halides, and now we discuss about the salts of oxo-acid, which is the third part that we'll discuss in the general characteristics of the compound of the alkali metal. So we go for it. So salts of oxo acids. Salts of oxo acids here. Here oxo acids are those in which the acidic proton is on the hydroxyl group with an oxo group attached to the same atom. Example, carbonic acid, which is H2CO3, OH2 twice, sulfuric acid, H2SO4, O2S, OH2 whole twice, and the alkali metal forms salts with all the oxo acids. They are generally soluble in water and thermally stable. They are carbonates M2CO3, and in most cases the hydrogen carbonate MHCO3 also are highly stable to heat. As the electropositive character increases down the group, the stability of the carbonate and hydrogen carbonate increases. Lithium carbonate is not so stable to heat. Lithium, being very small in size, polarize a large CO3 2 minus and ion, that leading to the formations of more stable Li2O and CO2. Its hydrogen carbonate does not exist as a solid. So here we go for it. And that will discuss about the anomalous property of lithium. So we are here to discuss about anomalous properties of lithium. So in anomalous properties of lithium, anomalous means is your abnormal. So abnormal properties of lithium that we discussed here one by one. So the first that we have property, the abnormal property of lithium is the anomalous behavior of lithium is due to the exceptionally small size of its atom and ion, and high polarizing power, that is changed by radius ratio. As a result, there is an increased covalent character of lithium compound, which is responsible for their solubility in organic solvent. Further, lithium shows diagonal relationship to magnesium, which has been discussed subsequently, and we'll discuss the another one, which is points of difference between lithium and other alkali metal. We go for it. Points of difference between lithium and other alkali metals. In the same way here, lithium is much harder and its melting point and boiling point are higher than the other alkali metal. Lithium is least reactive but the strongest reducing agent among all the alkali metal. On combustion in air, it forms mainly monoxide Li2O and the nitrides Li3N. Unlike other alkali metal, LiCl, which is lithium chloride, is deliquescent and crystallizes as hydrate. LiCl dot 2H2O, whereas other alkali metal chlorides do not form hydrates. Lithium hydrogen carbonate is not obtained in the solid form, while all other elements form solid hydrogen carbonate. Lithium, unlike other alkali metal, forms no ethanide on reaction with ethine. Lithium nitrate, when heated, gives lithium oxide Li2O, whereas other alkali metal nitrates decomposes to give the corresponding nitrides, which is being as follows. For LiNO3 will give 2 Li2O plus 4NO2 plus O2, 2 NaNO3 will give 2 NaNO2 plus O2, where LiF, lithium fluoride, and lithium dioxide that are comparatively much less soluble in water than the corresponding compound of the other alkali metal here. Now we discuss about the points of similarities between lithium and magnesium. Between lithium and magnesium. So here the similarities between lithium and magnesium is particularly striking and arising because of their similar sizes, atomic radii. Lithium is 152 pm and magnesium is 160 pm. Ionic radii, lithium is your 76 pm and magnesium, which is Mg2 plus, is your 72 pm. The main points of similarities are both lithium and magnesium are harder and lighter than other elements in the respective groups. Lithium and magnesium react slowly with water. Their oxides and hydroxides are much less soluble, and their hydroxides decomposes on heating. Both form a nitride Li3N and Mg3N2 by direct combinations with nitrogen. The oxide Li2O and MgO do not combine with excess oxygen to give any superoxide. The carbonates of lithium and magnesium decomposes easily on heating to form the oxide and CO2. Solid hydrogen carbonate are not formed by lithium and magnesium, where both LiCl and MgCl2 are soluble in ethanol. Both LiCl and MgCl2 are deliquescent and crystallizes from aqueous solution as hydrates. LiCl 2H2O and MgCl2 and 8H2O here. So now we discuss about some important compounds of sodium. explain some important compounds of sodium here. Industrially, the important compounds of sodium include sodium carbonate, sodium hydroxide, sodium chloride, and sodium bicarbonate. And the large scale production of these compounds and their uses are to be described. We'll discuss the sodium carbonate, which is washing soda. Which is Na2CO3.10H2O. This is washing soda. In the same way here, sodium carbonate is generally prepared by the solvay process, and in this process the advantages is taken of the low solubility of sodium hydrogen carbonate, whereby it gets precipitated in the reactions of sodium chloride with ammonium hydrogen carbonate. The latter is prepared by passing CO2 to the concentrated solutions of sodium chloride saturated with ammonia, where ammonia carbonate followed by ammonium hydrogen carbonate that are formed, and the equations for the complete process that may be here is as follows: 2NH3 plus H2O plus CO2 will give NH4 twice CO3, NH4 twice CO3 plus H2O plus CO2 will give 2NH4 HCO3. Another is NH4 HCO3 plus NaCl will give NH4Cl plus NaHCO3. Sodium hydrogen carbonate crystal separates. These are heated to give sodium carbonate, so that will be 2NaHCO3 will give Na2CO3 plus CO2 plus H2O. In the same way, in this process, NH3 is recovered when the solution containing NH4Cl is treated with CaOH2 ice, and calcium chloride is obtained as byproduct, and that will be forming 2NH4Cl plus CaOH2 ice give 2NH3 plus CaCl2 plus H2O. So it may be mentioned here that the solvay process cannot be extended to the manufacture of potassium carbonate, because potassium hydrogen carbonate is too soluble to be precipitated by the additions of ammonia hydrogen carbonate to the saturated solutions of potassium chloride. Now we'll discuss about the properties here, and so we go for it. Sodium carbonate is a white crystalline solid which exists as a decahydrate, which is Na2CO3.10H2O. This is also called a washing soda. It is readily soluble in water, and heating the decahydrate loses its water of crystallization to form the monohydrate above 373 Kelvin. The monohydrate becomes completely anhydrous and changes to the white powder that called soda ash. Is Na2CO3 plus 10 H2O will give at 375 Kelvin Na2CO3.H2O plus 9H2O, Na2CO3 dot H2O, then 373 Kelvin, Na2CO3 plus H2O. So carbonate, part of the sodium carbonate that get hydrolyzed by water to form an alkaline solution, which is CO3 2 minus plus H2O, HCO3 minus plus OH minus. Now we talk about for the uses here, and that what we'll have as well. So here it is used in water softening, laundering and cleaning. It is used in the manufacture of glass, soap, borax and caustic soda. It is used in the paper, paints and textile industry. It is an important laboratory reagent both in qualitative and quantitative analysis. Now we'll discuss about the sodium chloride, which is NaCl. Okay. This is all about what we discuss about sodium carbonate, which is washing soda. Now we'll discuss about sodium chloride, which is NaCl. Here the most abundant sources of sodium chloride is seawater, which contain 2.7 to 2.9% of mass of the salt. And in tropical countries like India, common salt is generally obtained by evaporation of seawater. Approximately 50 lakh tons of salts are produced annually in India by solar evaporation. Crude sodium chloride generally obtained by the crystallizations of brine solution that contain the sodium sulfate, calcium chloride and magnesium chloride as impurities. Calcium chloride CaCl2 and magnesium chloride MgCl2 are impurities because they are deliquescent, which is absorb moisture easily from. So on the same way that we discuss about it, so that has been filtered and to obtain a pure sodium chloride, that the crude salt is dissolved in minimum amount of water and filtered to remove insoluble impurities. The solution is then saturated with hydrogen chloride gas. Crystals of pure sodium chloride that separate out, and calcium and magnesium chloride that being more soluble than solid chloride, sodium chloride, that remain in the solution. Sodium chloride melts at 1081 Kelvin. It has a solubility of 36 gram in 100 gram of water at 273 Kelvin, where the solubility does not increase the appreciably used with increase in temperature. Now we discuss about sodium chloride uses here, that what will be important here. So we go for the same, the uses. In terms of the uses, it is used as common salt or a table salt for domestic purposes, and it is used for preparations of Na2O2 and NaOH and Na2CO3 as well. Now we discuss about another one, which is your sodium hydroxide, which is the caustic soda NaOH. Sodium hydroxide, which is your caustic soda, and that is your NaOH. Okay, on the same way we have to discuss about it. So Here in that, sodium hydroxide is generally prepared commercially by the electrolysis of sodium chloride in Castner cell, and a brine solution is electrolyzed using a mercury cathode and a carbon anode. Sodium metal discharge at the cathode that combine with mercury to form a sodium amalgam. Chlorine gas is evolved at the anode, and that is being at cathode. Na plus turn in the presence of Hg, you get Na, that is amalgam. At anode, Cl minus, it will give half Cl2 plus electron. So the amalgam is treated with water to give the sodium hydroxide and hydrogen gas here, and where 2 Na, that is amalgam, plus 2 H2O will give 2 NaOH plus 2 Hg plus H2. Okay, so on the same way, here the sodium hydroxide is a white translucent solid. It melts at 591 Kelvin here, and on the same way, that it is readily soluble in water to give a strong alkaline solution. Crystal of sodium hydroxide that are deliquescent, and that the sodium hydroxide solution of surface that react with CO2 in the atmosphere to form Na2CO3, and that we go for here in the detail about it as well. Now we discuss about the uses of sodium hydroxide, which is caustic soda. So the uses here, where it is used in that the manufacture of soap, paper, artificial silk, and the number of chemicals, and in petroleum refining, in purification of bauxite, in a textile industry for mercerizing cotton fabrics, and for the preparations of pure fat and oil, and as a laboratory reagent. I will discuss about another one, which is being about sodium hydrogen carbonate, which is baking soda, NaHCO3. Sodium hydrogen carbonate, which is baking soda, NaHCO3. Here in sodium hydrogen carbonate is known as a baking soda, and because it decomposes on heating to generate the bubbles of carbon dioxide, leaving holes in cakes and pastries and making them light and fluffy. As fluffy, and sodium hydrogen carbonate is made by saturated solutions of sodium carbonate with carbon dioxide, and the white crystalline powder of sodium hydrogen carbonate being less soluble, that gets separated out, and that will be going for an equation here, which is Na2CO3 plus H2O plus CO2 will give Na2NaHCO3. Sodium hydrogen carbonate is a mild antiseptic for skin infection. It is used in the fire extinguisher as well. In the same way, we'll discuss another one, which is the biological importance of sodium and potassium. So we go for it. That will be surely been the last one. Then we'll discuss the rest in the next coming class. Biological importance of sodium and potassium. So biological importance of sodium and potassium here, Here, a typical 70 kg man contains about 90 gram of Na and 170 gram of potassium, compared with only 5 gram of iron and 0.06 gram of copper. Sodium ions are found primarily on the outside of the cells and being located in a blood plasma and is an interstitial fluid which surrounds the cell. These ions are participate in the transmissions of nerve signals and in regulating the flow of water across the cell membranes and in the transport of the sugar and amino acids in cells. Sodium and potassium, although so similar chemically, differ quantitatively in their ability to penetrate cell membranes, in their transparent mechanism, and in their efficiency to achieve enzymes. Thus, potassium enzymes are the most abundant cation within cell fluids, and where they activate many enzymes, participate in the oxidations of glucose to produce ATP, and with sodium, and that are responsible for the transmissions of nerve signals. There is a very considerable variations in the concentrations of sodium and potassium ion that is found in the opposite sides of the cell membrane. As a typical example, in blood plasma, the sodium is present into the extent of 143 m mole liter inverse, and where the potassium level is only 5 m mole liter inverse within the red blood cell. These concentration changes to the 10, and that is 105 as well. And there the ionic gradient demonstrate that the discrimination of mechanism that is called sodium potassium pump operates across the cell membrane, which consume more than one third of the ATP used by our resting animal and about 15 kilogram per 24 hours in the resting human as well. So we'll discuss the rest of the class in the next coming class, and that will be ending it up here only. That is, in the 19th class we'll discuss about the group 2 element, which is alkaline earth metal, and that is of course being an important one too. So other than that, here, before ending it up, it's a huge request to all our viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Before ending it up, we had done your physics part 1 we had started with, and even though part 2 we are dealing, we will be dealing after completing the part 1, and we are dealing with the chemistry, and other than that we are dealing with the quantitative aptitude, where we had started with arithmetical ability, and we are near to complete that. After that we had done your reasoning, which is your verbal reasoning and the non-verbal reasoning. Coming towards chemistry, here we had done your part 1, which is some basic concepts of chemistry, the structures of atom, classifications of element and periodicity in properties, chemical bonding in the molecular structure, states of matter, thermodynamics, equilibrium. In unit 8, which we have to cover up the redox reaction, which we had completed, that is the classification ideas of the redox reaction, oxidation reduction reaction, redox reaction in terms of the electron transfer reaction, oxidation number, redox reactions and electrode processes. In unit 9 we have to cover up the hydrogen, which we had completed, that is the positions of hydrogen in the periodic table, dihydrogen, preparations of dihydrogen, properties in the dihydrogen, hydrized water, hydrogen peroxide, H2O2, heavy water, dihydrogen as a fuel. Unit 10 we are dealing with the S block element. Unit 11 is P block element. Unit 12 is organic chemistry, some basics, principles and technique. Unit 13 is your hydrocarbon. Unit 14 is environmental chemistry. So here we're gonna end up with. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you.